So what do I mean by no oxygen in the blood? This came from a paper from our friend Jerry Pollack, and I'm not sure it's been published yet, so I need to be a little bit circumspect about what I say here. But I would say, as is usual for Jerry, it was a brilliant paper full of good logic and sound reasoning. And let me just give you, I think, a highlight, which probably is okay. So the idea is that we have this air, right? And we breathe in the air into our lungs, or let's say take in the air into our lungs, and that the important part of the air is one of the constituents, which is called oxygen, which is in a form of a gas, and that oxygen gas diffuses from the air in our lungs through the alveolar, that's the little bubble membrane, and then through the capillaries, through the wall, essentially through the blood vessel wall of the lungs, which is the capillary wall, and from there through the red blood cell wall membrane, it's membrane, not a wall, and into the red blood cell, where it combines with hemoglobin and is then buried by hemoglobin to the rest of the body. So let me just say that a little bit more succinctly. The idea is we have air, which is 21 or so percent oxygen, about 77, 78% nitrogen, and 1% other more so-called inert or noble gases. The oxygen in the air is in the form of a gas, obviously, and that gas called oxygen diffuses through three membranes to get from the air in our lungs into the red blood cell. So Jerry asked a very simple question. So this diffusion through these three membranes, the interesting thing is you can measure that the oxygen level is lower in exhaled air than in inhaled air, but the nitrogen, which is another gas level, is essentially identical in inhaled and exhaled air. Now, the interesting thing about that is if you look and I would say believe what we're told with physics and chemistry about the relative size of atoms, including gases, then it's clear that nitrogen gas is smaller than oxygen gas. So the question he asked is, what is the mechanism that allows oxygen, the larger molecule, to diffuse through these three membranes and show up in the blood and in the red blood cell, but the smaller molecule, nitrogen, isn't able to do that? And that's similar to the question I asked with how do you get the mRNA out of the nucleus, since it has a membrane around it, without letting the hydrogen ions, which are 1,000 or 1,000,000 times smaller, diffuse in and out, and you can prove that the pH, which is a reflection of the hydrogen ion, is different in the cytoplasm and the nucleus? And the answer is you don't. And so then scientists come in, and as is their usual habit, they have a theory. The theory gets disproven. In other words, you can't possibly have the smaller molecule not diffuse and the bigger molecule, it can. And so then they have to invent another principle or theory to explain that. So they postulate these whirligigs that somehow bind to mRNA and deposit them in the outside, or some sort of mechanism or pump that pumps against the gradient and specifically, even though you can never find the pump. And then 10 years later, the pump gets disproven, and then they invent something else, and it just keeps going. And they never go back and say, I wonder if the whole theory was incorrect. And it turns out that even when I say the oxygen is less in the exhaled air, it's not actually the oxygen that's less, it's the charge is different. And even when you measure hemoglobin to see how oxygenated it is, so you can measure with a pulse oximeter, you think you're measuring oxygen, but you're actually measuring the configuration of the hemoglobin, which changes depending on the charge that the hemoglobin is exposed to. So in other words, this whole thing is a reflection of electromagnetism, not the diffusion of a gas. The gas doesn't diffuse. The oxygen seems to be a what we erroneously call, it's hard to even get the words right here because the words are so messed up, but let's just say an electron or charged donor, when the exhaled air has lost its charge, then you think that there's less oxygen, but what there is less charge in the air. The hemoglobin picks up the charge, changes its configuration, and then you interpret that as it's picked up oxygen. There is no gas oxygen in there. That couldn't possibly have diffused. It's just that there was a charge donation that seems to be a property of oxygen, and that is what actually runs the process. The importance of this is that if you knew that's why you breathe, is not to get oxygen, but to get a charge, you would understand that getting a charge in some other way might actually help you, quote, breathe better. I mean, it wouldn't help you breathe better, but it would accomplish the same thing as breathing does. And so this has actually been tested in funny sort of ways that the oxygen is allegedly carried in the blood. So they actually taken dogs, and this was done by Cowan plasma, and they drained all the blood out of the dog, and then they infused back in isotonic Cowan plasma, which is full of charge but not much oxygen, and no way to carry the oxygen because there's no blood in the dog. And the dog seemed to recover and actually not only be fine, but be better. And what that tells you is that the salient, important thing, so-called, that was being used in the blood is not a gas called oxygen, but a charge. And so you can get the charge from sunlight, from being on the earth, from crystals, from Cowan plasma or RC plasma, or lots of other things. And you can end up helping people with their energy and their metabolism and just their overall health through knowing the reality instead of, well, I need to somehow give them more oxygen. So there's more to come on that, but I don't want to say much more about that. Eventually, hopefully that article will come out soon, and then we can maybe do a whole piece on it.